Wow, what an incredible view.
Yes, Keenan. This P. Crystallinus is some of the best I've ever seen. You know, Keenan, you're a pretty fun guy, but you don't really compare to these P. Crystallinus.
Well, it doesn't look very impressive. It's not even moving.
But you know what? They actually shoot out their spores pretty fast.
So why would the spore have to move so fast?
Well, P. Crystallinus grow in cow feces like this one, but they need to be ingested by cattle to spread out. Therefore, they shoot their spores pretty far away in order to spread to new grass where they can grow.
So how does it achieve such a great acceleration?
The P. Crystallinus has to build up an extreme amount of water pressure inside it to propel its spores. You know, my good friend Lucas could probably explain this better than I. Lucas, can you help us understand the kinematics of P. Crystallinus?
So in a real-life scenario where there is air resistance, the spore only goes about 1.14 meters away from where it originated on the feces. However, we can calculate a much greater distance it would travel if air resistance was neglected. So we know the initial velocity the spore has as it leaves its original sporegium is about 42.35 meters per second. And this is at a 45-degree angle, ideally towards the sun. So by using a triangle, we can find out that the y component and x component both equal 29.946 meters per second. So using this information, we can then use a simple kinematic calculation to solve for the time that the spore is in projectile motion. So the final height of the spore would be 0 meters. It would be on the ground. The initial height would be the height of the spore, which is about 25 millimeters, plus the velocity in the y direction initially, which is as calculated in the triangle, 29.946 times the time plus half of the acceleration, which is the acceleration due to gravity, which is negative 9.81 meters per second squared times the time squared. So solving for this equation, we find that the time equals 6.105 seconds. With this time, we can then substitute it in for the x component using the same kinematics equation. Here, we find that the final x value will be 182.8 meters. This would be the distance the spore will travel if there was no air resistance.